There are places on Earth where mountains do not disappear because of erosion. They disappear because we move them. Places where machines taller than houses carry loads heavier than passenger jets. Where explosions tear open millions of years of geological history in seconds. And where holes have grown so enormous that standing at the edge can make the largest mining trucks below look like toys. These are not ordinary mines. They are landscapes being rewritten in real time. And behind every ton of rock removed lies something the modern world cannot seem to live without. Copper carrying electricity through our cities. Iron becoming the steel around us. Gold moving through global markets, and minerals hidden inside technologies most of us use every day. Across deserts, mountains, jungles, and frozen wilderness, humanity has pushed mining to a scale our ancestors could scarcely have imagined. But among thousands of operations scattered across the planet, a handful have become something else entirely. They have become giants. And our journey begins in the American West, where more than a century of mining has created a hole so vast that the first thing you lose at its edge is your sense of scale. 1. Bingham Canyon Mine, Utah, United States. 25 miles southwest of Salt Lake City, Utah, the ground suddenly falls away. At first, the human eye struggles to understand what it is seeing. The opposite side looks distant. Terraces spiral downward in enormous steps. Roads descend toward a bottom that seems impossibly far below, and scattered across those roads are tiny moving objects. They look like insects. They are not. They are haul trucks, some of the largest vehicles designed to move on land. And the fact that they appear so small tells you almost everything you need to know about the scale of this place. Canyon Mine, also known as the Kennecott Copper Mine. For more than a century, humans have been cutting deeper and wider into this section of Utah's Oquirrh Mountains. Today, the excavation stretches roughly 4 kilometers across and reaches approximately 1.2 kilometers deep. But numbers alone fail here. To understand Bingham Canyon, you have to imagine removing part of a mountain, then continuing downward. Year after year, decade after decade, generation after generation, until the mine itself becomes a new geographical feature. The story begins long before the first shovel touched the ground. Tens of millions of years ago, molten rock moved upward beneath this region. Heat and mineral-rich fluids circulated through fractures underground. Copper, gold, silver, and molybdenum became distributed through enormous volumes of rock. But there was a problem. The valuable minerals were not concentrated neatly into one convenient vein. They were scattered. Tiny amounts hidden inside an immense body of stone. For early miners, this kind of deposit was frustrating. The copper was there, but recovering it economically required something that did not yet exist: scale. And when technology finally caught up, the mountain's fate changed forever. Large-scale open-pit mining began at Bingham Canyon in the early 20th century. The idea was radical. Instead of following narrow underground veins, miners would remove enormous quantities of rock from the surface. Not just the richest pieces, everything required to reach the ore. The mountain would be dismantled systematically, layer by layer, bench by bench, blast by blast, and that basic strategy still defines the landscape today. Before rock can be moved, it must first be broken. Drilling machines create patterns of deep holes across carefully selected sections of the mine. Explosives are loaded. The area is cleared. Then comes the moment when geology meets industrial force. The blast. For a fraction of a second, the mountain seems to lift. Rock fractures. Dust expands outward. A section of ground that remained solid for millions of years is transformed into material that machines can finally move. Then the giants arrive. Electric shovels lower enormous buckets into the broken rock. One scoop, then another. Each load disappears into haul trucks capable of carrying hundreds of tons. And then those trucks begin climbing relentlessly up roads carved around the walls of the pit. This is where the true scale of Bingham Canyon becomes difficult to comprehend. A mining truck may tower over a person. Its tires alone can stand several meters high, but viewed from the rim of the mine, the same vehicle almost disappears. The pit is simply too large. A truck can spend a significant part of its working cycle traveling from the depths of the mine toward processing facilities, only to turn around and descend again. Day after day. Because an operation this large cannot simply stop when the sun disappears. Lights come on, shifts change, the machines continue. The mine has its own rhythm, almost like a city turned upside down, except instead of skyscrapers rising toward the sky. Everything here descends into the earth. But the most surprising part comes after the rock leaves the pit, because most of what has been removed is not copper. The valuable material may represent only a small fraction of the total mass. The rest must be separated, crushed, ground, processed again and again. Huge pieces of rock become smaller rocks become particles, and from an overwhelming volume of material, copper-bearing minerals are gradually concentrated. This is the hidden reality behind many modern mines. The valuable metal may be measured in fractions. The operation required to recover it is measured in mountains. And that copper does not remain in Utah. It enters a global system. Eventually, copper from operations like Bingham Canyon may become electrical wiring, power infrastructure, construction materials, industrial machinery, electronics, transportation systems. The metal extracted from this enormous hole can eventually disappear into objects so ordinary that nobody thinks about where they began. Flip a switch, and somewhere behind the wall, copper carries the current. Charge a device. Copper helps move the electricity, build a power grid. And suddenly, the connection between distant mines and modern civilization becomes impossible to ignore. The mine looks remote. Its products are everywhere. But operating on this scale creates another problem. When humans excavate a mountain, the mountain responds. In April 2013, an enormous landslide tore through Bingham Canyon. Tens of millions of cubic meters of rock moved down the northeastern wall of the pit. The collapse was immense. Mining infrastructure was damaged, equipment was buried, operations were disrupted. But remarkably, monitoring systems had detected movement in the slope beforehand. Workers were evacuated from the danger zone. The disaster became a powerful demonstration of something modern mining has learned the hard way. A pit this large is never completely still. The walls move, rock expands, fractures grow, gravity never takes a day off. Engineers monitor slopes continuously because the mine is not simply an excavation, it is an evolving landscape. Stand at the edge of Bingham Canyon today and the contradiction is difficult to miss. The mine is an extraordinary achievement of engineering, and at the same time, it is a reminder of how much material civilization demands. Millions of tons moved, mountains reshaped, entire systems built to recover metals most people will never see in their raw form. And yet Bingham Canyon is only our first stop, because thousands of kilometers south of Utah, there is another place where the search for copper entered an environment even less forgiving. A desert so dry that some weather stations have gone years with almost no measurable rainfall. A landscape where water can be as strategically important as the metal beneath the ground. And there, on the edge of one of the driest places on Earth, humans created another enormous excavation. 2. Chuquicamata, Atacama Desert, Chile. From above, northern Chile looks almost lifeless. The Atacama Desert stretches toward the horizon in shades of brown, red, and pale gold. Rain is extraordinarily rare in its driest regions. Vegetation disappears, rivers vanish. And the landscape begins to resemble the surface of another planet. Yet beneath this apparent emptiness lies extraordinary mineral wealth. Copper, enormous quantities of it. And near the city of Kalama sits one of the most famous names in the history of copper mining. Chuquicamata. For generations, miners carved downward into this desert. The pit grew wider, then deeper, then larger still, until the excavation became one of the world's great open-pit mining landmarks. But Chuquicamata presents a contradiction. The deeper an open pit becomes, the farther every truck must travel. Imagine standing at the bottom. Your truck is fully loaded. The processing facilities are far above. You begin climbing. One switchback, then another, then another. Fuel is consumed, simply escaping the hole. Tires wear. Time disappears. The deeper the mine becomes, the more expensive every ton can become to move. Eventually, an open pit can begin working against itself, and Chuquicamata reached that threshold. So engineers made an extraordinary decision. The mine would not stop. It would change direction. Instead of continuing only downward from the sky, the operation would begin disappearing beneath the desert. Chuquicamata started transforming from a giant open pit into a major underground mining operation. The resource remained. The mining method changed. A new world was being built beneath the old one. Tunnels, crushing systems, underground infrastructure. An industrial network hidden beneath a pit already enormous enough to dominate the landscape above. It is almost as if humanity dug one gigantic mine, then decided to build another underneath it. And here, the story of scale becomes something more complicated. Because mining in the Atacama is not simply a battle against rock, it is a battle against environment. Water is precious, dust is constant, distances are enormous, temperatures can shift dramatically between day and night. Equipment must survive, workers must survive, and production must continue. The desert does not care about schedules. Copper, however, has become increasingly difficult for the modern world to ignore. Electric grids need it. Renewable energy systems need it. Electric vehicles use it. Data centers need it. Construction depends on it. As the world becomes more electrified, copper becomes less visible to ordinary people, and more important to almost everything they use. That gives places like Chuquicamata an unusual power. A seemingly empty desert becomes connected to cities thousands of kilometers away. Rock removed in Chile eventually becomes infrastructure somewhere else. The Atacama may feel isolated. Its copper is not. Yet even Chuquicamata is not where our first journey ends. Because if copper can justify removing mountains, what happens when the target is gold? To answer that, we must travel thousands of kilometers east, across continents, into Central Asia, into another desert, a place where summer heat can become brutal and winter cold can cut across an almost empty landscape. There, inside Uzbekistan's Kizilkum Desert, lies an excavation of extraordinary scale. But unlike Utah, and unlike Chile, the treasure hidden here has fascinated humanity for thousands of years. Gold. And at Muruntau, the search for it has become so enormous that the mine itself seems to swallow the horizon. 3. Muruntau Gold Mine, Kyzylkum Desert, Uzbekistan. The Kyzylkum Desert does not advertise what lies beneath it. From the surface, much of the landscape appears endless. Dry plains, low ridges, dust, heat, silence. The name Kyzylkum translates roughly as the red sand. It stretches across a vast region of Central Asia, and somewhere inside this seemingly empty world, humans discovered one of the greatest concentrations of gold ever mined. Muruntau. From the air, the operation appears almost unreal, an enormous opening cut into the desert floor. Terraces descend in giant steps, roads spiral toward the depths, trucks move continuously between benches. Once again, they appear tiny. Once again, they are enormous. The landscape is simply larger. Gold mining often begins with an image of a prospector, a pan, a river, perhaps a nugget shining beneath shallow water. Muruntau destroys that image completely. Here, gold is not recovered one nugget at a time. It is pursued on an industrial scale. The challenge is not simply finding gold, it is moving enough rock to reach it. Ore must be drilled, blasted, loaded, transported, crushed, processed, and from enormous quantities of material, comparatively small quantities of gold finally emerge. That difference between the amount of rock handled and the amount of metal recovered is what makes modern gold mining so astonishing. A finished gold bar is compact, dense, almost deceptively simple, but behind it may stand an industrial chain stretching across kilometers. At Muruntau, the desert becomes part of the story. Every operation this remote must solve problems beyond geology. Workers need transportation, machines need maintenance, processing systems need energy. Water must be managed carefully. Supplies must arrive consistently. A mine of this scale cannot function as a lonely hole in the ground. It becomes an ecosystem. Roads, power, processing plants, workforces, logistics, an entire industrial world constructed around something hidden beneath ancient rock. And this is where the first three giants reveal something important. Bingham Canyon shows what happens when humanity removes a mountain for copper. Chuquicamata shows what happens when an open pit becomes so deep that mining must retreat underground. Muruntau shows how enormous the search for gold can become when geology concentrates enough of it in one place. 3 mines, 3 landscapes, 3 different stories. But the scale is about to change again, because our next operation does not sit conveniently beside a major American city. It does not lie beneath an open desert sky. It rises into remote mountains where tropical weather meets extreme altitude. A place where miners have worked among clouds, steep slopes, and some of the most challenging terrain surrounding any major mining district on Earth. And there, gold is only half the story. Because hidden within the mountains of Papua, Indonesia, lies one of the most extraordinary copper and gold mining districts ever developed, Grasberg. And to reach it, we have to climb.